Hello students, welcome to the next session of your rapid revision in mathematics in preparation for your CBSE Board Examination in mathematics. So today we'll be discussing on two important chapters for your board examination, vector algebra and three-dimensional geometry. First I will go through the topics of three-dimensional geometry because that has more weightage than vector algebra, and we have already completed an MCQ discussion for this. Please watch that as well because around 5 MCQs or 1 mark questions are expected from these two chapters. 5 marks, my dear students. And apart from that, for three-dimensional geometry, we are also expecting a 2 mark and another 5 mark question. So please, you have to give a lot of time for this chapter, three-dimensional geometry. I'll be discussing a lot of 2 mark and 5 mark from three-dimensional geometry today. And in vector algebra, we are only expecting 1 2-mark question apart from the 1 mark questions of vector algebra. Just 1 2 mark question. So you just have to give only that much importance to vector algebra. But still, I have tried to include so many important 2 mark questions in vectors as well. So let us go to the question straight away. Do not waste time now. Okay, in three-dimensional geometry, first most important expected question is about shortest distance between two lines. Before starting with the question, let me tell you something about 3D geometry. There are a lot of formulas in three-dimensional geometry, but every concept in three-dimensional geometry can be described using 2 formulas. Either you can do it with the Cartesian form or you can do it in the vector form. So we don't have to learn both the forms. You just need to know how to convert the given equation of a line into the Cartesian form if required or to the vector form if required, based on which concept you're trying to do. Here shortest distance is your concept, and I prefer my students to learn the vector formula for the shortest distance between two lines. We do have a Cartesian form, but I choose formulas based on how easy it is to do. The Cartesian form is a very complicated formula, so it's very difficult to get the answer in. Okay, so we expect every student to do this concept using vector form. So we try to keep the equation of the straight lines in vector form. If the question gives in Cartesian form, just change it to vector form. So here we are trying to find the angle between two lines. So here angle between two lines is based on the formula cos theta is equal to b1 vector dot b2 vector divided by magnitude of b1 vector magnitude of b2 vector. Yes, angle between two lines is also based on the vector formula. You can see that every straight line is represented by r vector is equal to a vector plus lambda b vector. Every straight line can be written in the vector form a vector plus lambda b vector. Here a vector is the first vector, which is the point on the line. B vector is the direction ratios of the line. It is the direction ratios of the line or the direction ratios of another vector parallel to the line. Parallel vectors have equal direction ratios, so we just use those as B. So from both the lines, I know what is B1, I know what is B2, so this is what we call as B1 vector and this is what we call as B2 vector. Just use them, B1 dot B2. How to find the dot product? Already we have studied this. 3 into 1 plus 2 into 2 plus 6 into 2, the dot product between two vectors. And the magnitude, root of magnitude of this vector, 9 plus 4 plus 36. 9, 3 squared plus 2 squared plus 6 squared. The next vector, 1 squared plus 2 squared plus 2 squared. Okay, just multiply and add it up. So you have 3 plus 4, 7, 7 plus 12, 19 by 9, this is root 49, which is 7, and this is root 9, which is 3. So answer is 19 divided by 21. 19 divided by 21. Therefore, what is my angle between the two lines? Theta cos inverse of 19 by 21. Cos inverse of 19 by 21. All of you, please learn the formula once again for angle between two lines. Good question for 2 marks. Okay, but I'm not saying it's important, because the same question can be asked for 1 mark also. It's a very simple question to do. But what I would say more important about this question is, this can come as an additional question in the 5 mark question. Like a question about 2 straight lines. And at the end they could simply ask, then hence find the angle between the 2 lines. Simply, just for namesake. So careful with the 5 mark, at the end they could make it tricky. So moving forward, next question please. Question 2, find the shortest distance between the 2 lines. Like I said before, I prefer to have the shortest distance formula in the vector form. The shortest distance formula in the vector form. So all of you identify, for the first line, this is A1 vector. For the first line, this is B1 vector. For the second line, the point is A2 vector, and for the second line, the direction ratios is B2 vector. The formula for shortest distance, all of you, I am writing both the formulas. Okay, shortest distance is equal to A2 minus A1 dot B1 cross B2 divided by the magnitude of B1 cross B2. But since distance is always positive, we put a modulus for this, because the dot product could become negative as well. So this is the formula for shortest distance between 2 skew lines. Okay, it's a very good concept for assertion reason. What are skew lines? What are skew lines? Non-parallel, non-intersecting, non-parallel, non-intersecting lines are called skew lines. Non-parallel, non-intersecting lines are called skew lines. So you're going to find the shortest distance between 2 skew. Let's check if it's parallel or not. Look at B1, B2. Do they have the same direction ratios? No, they don't have. This is 1:2:3. This is 2:4:5. Okay, so if this was -6 by chance, if this was -6, then I could have written this 2:4:6 as 1:2:3, which is the same. But it's -5. So hence they are not parallel. So if they are parallel, shortest distance has another formula. Let's write that as well. Shortest distance formula for parallel lines. The points are different, so A2 minus A1 cross B divided by the magnitude of B. But keep in mind, when you're doing this, okay, when you're doing this, for the numerator, you have to take a magnitude, because cross product is a vector. So you have to take the magnitude of the numerator divided by the magnitude of B. This is for parallel lines who have the same direction ratios, vector B. Keep in mind, very important, the most expected question for you people in this year's board exam from 3-dimensional geometry, shortest distance between 2 lines. Somewhere or the other, maybe inside a 5-mark question, maybe in a 2-mark question, they could simply ask you, what is the shortest distance between 2 lines? Okay, now here, let me go for the answer. I'm trying to find what is A2 minus A1. So first, A2 minus A1. Subtract the 2 vectors, 4 and 1 over there. So 1 minus 4 minus 3i. Minus 1 plus 1, 0j. 2 and 0k, it's 2k. So this is my A2 minus A1. Now I'm trying to find B1 cross B2. And I hope everybody knows how to find the cross product between 2 vectors. Method of determinant, ijk. The first B1 vector, it's 1, 2 and minus 3. The second B2 vector, 2, 4 and minus 5. So the answer is I into minus 10 plus 12 is 2. minus j into minus 5 plus 6 1 plus k into 4 minus 4 0. So my cross product is 2i minus j plus 0k. I got the cross product, I got a2 minus a1. Now I am going to find the shortest distance for skew lines. I want to find the dot product between a2 minus a1 and b1 cross b2. Minus 3 multiplied with 2. Minus 3 multiplied with 2. Next one, 0 with minus 1. 0. And then you have 2 with 0. 0. Divided by the magnitude of b1 cross b2, which is the square root of 2 squared plus minus 1 squared plus 0 squared. So answer is 6 divided by the square root of 5. The shortest distance between the two lines, 6 divided by root 5. So I hope everybody is clear with the answer. Please make sure the formula is what matters. I don't think there is anyone in this session who doesn't know how to find the difference of two vectors, how to find the cross product between two vectors. If you do not know, then you are in big trouble. Please go home and practice it. If the session ends, you have to practice dot product, cross product and subtraction, addition of vectors. It's the most basic thing for getting any question vectors in 3D. Okay, fine? Yes, what's the doubt? Samil. Come on, what's the doubt? So parallel line condition should be that the value for B is simplified. Yes, the value for B vector should be compared in the simplest ratio. Sometimes I said 2, 4 minus 6 is not same as 1, 2 minus 3. But 2, 4 minus 6 when simplified will be 1, 2 minus 3. So you should compare it in the simplified form. Okay, fine. Moving onwards. Question number 3. Find the shortest distance between the two lines and hence verify whether the lines are intersecting or not. So here, I'm not planning on doing this question much because like I said, shortest distance, I prefer doing it with the vector form. So here, my equation is in the Cartesian form. So Cartesian form, x minus 1 by 2 equal to y minus 1 by 3 equal to z minus 0 by 1. I'm writing it in the Cartesian form of a line in the correct standard form. So from this, the coordinates of the point A1 is 1i, the numerator, and the next one is minus 1j, and the next one is 0k. And the direction ratios are 2i plus 3j plus 1k. Okay? Similarly, take the next line, please, all of you. All of you, please take the next line. X plus 1, or I could say x minus 1 divided by 5, y minus 2 divided by 1, and please be careful, z equal to 2. My dear students, this is the most difficult thing about three-dimensional geometry. They do not like to give the equations of the straight lines in the standard form. Okay, so we have to write it in the standard form. This is one very confusing form where one part of the equation is separated using a comma. That means that it's a part of the equation where the direction ratio is 0. The part of the equation which is separated by comma means it's a part of the equation where the direction ratio is 0. And z equal to 2 means z minus 2. Z equal to 2 means z minus 2 equal to 0. So you have to rewrite in the correct form, and from this, what is A2 vector? Minus 1i plus 2j plus 2k. And what is the B2 vector? 5i plus 1j plus 0k. Got it? Clear, all of you? All of you, please, very important. First, identify a1 vector, a2 vector, b1 vector, b2 vector. Shortest distance. I'll write the formula once again. a2 minus a1 dot b1 cross b2 modulus divided by magnitude of b1 cross b2. Both the direction ratios are different, so it's a skew lines. Now they're asking, hence verify whether the lines are intersecting. You just have to write one last statement for it. Look at the previous question. You got the shortest distance as a non-zero value. If the shortest distance is a non-zero value, that means there is a distance between the two lines. So they are not intersecting. If the shortest distance between the two lines is 0, we can conclude that the lines are intersecting. So I don't want to do this again and waste my time. So I'm going to say here, if shortest distance equals 0, then the lines are intersecting. The shortest distance equal to 0, then the lines are intersecting. This could be a very good 3-mark question. Okay, the question could be for 3 marks, but we are not expecting a 3-mark question. I'm going to add one more concept to this in the next question. At that time you will understand. I'm not sure of the next question. Anyway, one question is coming like that. The question is, find the shortest distance between two lines and verify whether the lines are intersecting or not. And if they are intersecting, then definitely it should be intersecting. Find the point of intersection. 5-mark question. 5-mark question, my dear students, very important. So here, I'm going to go to the next question. Okay, here again is shortest distance between two lines. I'm just going to help you to write it in the standard form. You will be solving it yourself. Okay, just helping you to write in the standard form. The first one, the first equation is x plus 1 equal to 2y equal to minus 12z. This is the equation of the first line. Writing it in the standard form, all of you. X minus 1 divided by 1. There is nothing in the denominator. It means the direction ratio is 1. And x minus the first coordinate minus 1. The second equation, 2y. The coefficient of every variable in the equation of a straight line should be 1. So here it's 2. So I can write this as y minus 0 divided by half. I'm just dividing 2 in the numerator and denominator. There is nothing in the denominator, so it's 1. So 1 by 2 in the denominator, and 2y becomes y when divided by 2, and there is no coordinate, so I'll put 0, minus 0. The third one, same idea, divide the numerator and denominator with minus 12, z minus 0 divided by minus 1 by 12. So the direction ratios of the line are 1, 1 by 2 and minus 1 by 12, and the coordinates are minus 1, 0, 0. So my vector A1 is minus 1i plus 0j plus 0k, and my vector B1 is 1i plus 1 by 2j minus 1 by 12k. My dear students, I'm just putting these kind of questions because if in the exam they ask you questions like this in the equation form and ask you to find the shortest distance, you are all very good at finding shortest distance maybe, but you do not know how to convert it. Then you will be in big trouble. That's why I'm giving you these questions. Convert these Cartesian forms to the vector forms and then write the correct A1 vector and B1 vector from it. Okay, I think it's clear. Fine. Next, second equation is, all of you please look at the second equation. X equals y plus 2 equals 6z minus 6. The first equation, x minus 0 by 1. There is nothing in the denominator, so it's 1. Second one, y minus 2 divided by 1. Third one, you can see 6 So divide 6 in the numerator, you get z minus 1. Divide 6 in the denominator, you get 1 by 6. Okay, so my A2 vector, all of you, 0i minus 2j plus 1k, and my B2 vector, 1i plus 1j plus 1 by 6k. Again, I'm just finding the vectors. Now it's your headache to find the shortest distance. Okay, shortest distance formula, you know, a2 minus a1 dot b1 cross b2 by magnitude. So repeatedly I am trying to help you to convert any different form of the equation of a line that can be given in the exam. You should be experts in converting it. If you cannot convert it, you will not be able to do this question. Okay, learn how to convert not orthodox equations into the standard equations of a straight line. Okay, next question. Show that the lines are intersecting, hence find the point of intersection. So this I'll do. How to prove that the lines are intersecting? This is what I said before. If they intersect, the shortest distance is supposed to be 0. The shortest distance between the two lines is supposed to be 0. So from this first equation, x minus 1 by 2 equal to y minus 2 by 3 equal to z minus 3 by 4. Okay, from this my a1 vector is 1i plus 2j plus 3k. My b1 vector is 2i plus 3j plus 4k. Now second equation, all of you, x minus 4 divided by 5, y minus 1 divided by 2 equal to simply z. So the coordinate is 0 and the direction ratio is 1. It's not a comma. Only when comma comes, you will say the direction ratio is going to be 0. Okay, fine. So here, what's my a2 vector? 4i plus 1j plus 0k. b2 vector, 5i plus 2j plus 1k. So I got the vectors correctly. Now let me find what's a2 minus a1. a2 minus a1. Okay, so a2 is here, a1 is here. 4 minus 1, 3i, 1 minus 2 minus 1j, 0 minus 3 minus 3k. Now b1 cross b2, method of determinant, I, j, k, b1 2, 3, 4, b2 5, 2, 1 equal to I into 3 minus 8 minus 5 minus j into 2 minus 20 minus 18 plus k into 4 minus 15 minus 11. Okay, 3 minus 8 minus 5, 2 minus 20 minus 18, then 4 minus 15 minus 11. So I got my b1 cross b2. Now I'm trying to find the shortest distance. Now here actually I need not show b1 cross b2 because they are saying that the lines are intersecting. If the lines are intersecting, then the shortest distance is 0, and that implies that the numerator, my dear students, if the shortest distance has to be 0, the numerator in the formula should be 0. Yes, the numerator in the formula should be 0. So I don't have to find the entire shortest distance here. Okay, the numerator is 0, then the shortest distance is 0. Let's try. a2 minus a1 is there. So 3 multiplied with minus 5 is minus 15. Then 18 with minus 1 is minus 18. Then minus 3 plus into minus 11 is plus 33. Minus 15 minus 18 33. Minus 33 plus 33, 0. So the shortest distance is 0. Got it? I don't have to substitute in the entire formula. If I know that the lines are intersecting, only do the numerator. If the numerator is 0, shortest distance is definitely 0. Okay? So the shortest distance is 0. The lines are intersecting. Please, it's a very, very good question for 5 marks this year. Please learn it. The shortest distance being 0, the lines are intersecting. Now I have to find the point of intersection. How to find the point of intersection? So carefully listen to the methodology. Okay? For finding a point, we need the Cartesian form. For finding the point, we need what? The Cartesian form. For finding shortest distance, we need vector form, but for the point, we need Cartesian form. Call the first equation equal to lambda, the second equation equal to mu. Then I can easily say from equation number 1, all of you, equation number 1, equation number 2. From equation number 1 implies x is equal to 2 lambda plus 1. Okay? Y is equal to 3 lambda plus 2. Enough. I need only 2 coordinates. You can write z also, but I am only interested in 2 coordinates. Okay? Z is equal to 4 lambda plus 3. Okay? Keep it. Equation number 2. X is equal to 5 mu plus 4. Y is equal to 2 mu plus 1. Z is equal to mu. All of you, Z is equal to mu. I got 3 sets of equations which belongs to the point of intersection of 2 lines. 2 lines are intersecting somewhere, and this point is XYZ. And that point is common to both the lines, my dear students. This particular point is common to both the lines. So you just look at it, all of you. You can see that XYZ belongs to both the lines. So I can simply compare these two. Can I say 2 lambda plus 1 is equal to 5 mu plus 4. 2 lambda plus 1 equal to 5 mu plus 4. Now next, let me take an easier equation to compare these two. Z says that 4 lambda plus 3 equal to mu. So I can substitute mu as 4 lambda plus 3. That implies 2 lambda plus 1 is equal to 5 into 4 lambda plus 3 plus 4. Just make a quick substitution, you can get lambda from this. So my idea is get 2 equations in lambda and mu, solve them like you solve in system of simultaneous equations of 2 variables. Lambda and mu are unknown values, just simply solve it. So you solve this over here, 2 lambda and 20 lambda is 18 lambda. This is 20 lambda, 2 lambda, 18 lambda. 15 plus 4 is 19. So 19, which comes over here as minus 19, makes it minus 18. So lambda equal to minus 1. So if lambda equal to minus 1, that implies mu is equal to minus 4 plus 3. Mu is also minus 1. Actually, I don't need to find both, but I'm just showing you that I can find both. Just one of them is enough. Substituting that in XYZ, I will get the point of intersection. Therefore, point of intersection, because it is the same for both. Yes, that's why it's called the point of intersection. XYZ. Substitute lambda is equal to minus 1 or mu equal to minus 1, whatever you want. Let me put mu equal to minus 1. Minus 5 plus 4, minus 1. Minus 2 plus 1, minus 1. minus 1. See what's the point of intersection? Minus 1, minus 1, minus 1. If you want, you put z lambda is equal to minus 1 also. Minus 1, minus 1, minus 1. You will get the same coordinates only. So this is a very good question for 5 marks this year, showing that the two lines are intersecting and finding the point of intersection from that. Just write both the equations in terms of lambda and mu. Write the xyz in terms of lambda, xyz in terms of mu. Compare them. Compare the corresponding values of xyz. You will get two equations in lambda and mu. Solve to get one of them. Get one, either lambda or a mu. Get one. Substitute that in any xyz. You get the point of intersection of the two lines. Yes, I believe everybody is clear. Yes. Any doubts you may ask? Quick. Any doubts you may ask? Quick. Okay, fine. So let me move forward. Question number 6. An insect is crawling. This is from the sample paper. As a new type of question for shortest distance. An insect is crawling along the line. The first equation is given, and another insect is crawling along another line. The second equation is given. At what points on the lines should they reach so that the distance between them is the shortest? The question is completely different. The question is not to find the shortest distance between the two lines straight away. Then it is easy. The question is to find what points on the line should they reach. Let me say the point is P over here. Let me say the point is Q over here. These are the 2 points on the two lines where the insects should reach so that the distance between the two insects is the shortest. The distance between the two insects is the shortest. So it's not to find D, but to find the points. That's the biggest problem. So let me call this point as x1, y1, z1, and this point as x2, y2, z2. Okay, and I should find what is x1, y1, z1. I should find what's x2, y2, z2. But I do know that x1, y1, z1 belongs to the first line and x2, y2, z2 belongs to the second line. Let me call this as the first line, and let me call this as the second line. And I want points. So like I said in the previous question, the coordinates of a point for a line can be obtained only through the Cartesian equation. So let me write the first line as Cartesian equation. Straight away you can write it x minus 6, y minus 2, z minus 2. Direction ratios 1, minus 2, 2 for the first line, equal to lambda. From this I'm writing the coordinates of x1, which is lambda plus 6, coordinates of y1 minus 2 lambda plus 2, coordinates of z1, which is 2 lambda plus 2. So I use the equation of line 1 to write the values of x1, y1, z1. It might look difficult, but the question is not difficult. You just need to be sensible only. Line 2 says equation is x plus 4 equal to, there is no j, so y minus 0, then minus k, so z plus 1 divided by direction ratios 3, direction ratio minus 2 and minus 2. Let me call it as mu. Now I can say my coordinates of the second point are 3 mu minus 4, y2 is minus 2 mu, and z2 is minus 2 mu minus 1. I got the points of x1, y1, z1, x2, y2, z2, but in terms of lambda and mu, I have to now somehow find what's lambda and mu. In the previous question, what was the technique I used to find lambda and mu? I said lambda and mu belong to the same point, so let me say they are equal. and I got two equations, I equated them. Here it won't work because it doesn't belong as the same point. They are two different points. But we are measuring the distance, all of you. We are measuring distance. Distance is always measured perpendicular to the line. Distance is always, see, I have drawn one line a little bit slanted way. It doesn't mean that they are not perpendicular. It's in space. It's in a space. So just to show that it's in space, I have drawn it a bit slanted. So they are perpendicular, but they are not parallel to each other. The two lines are not parallel to each other, but PQ is perpendicular to L1 and L2. PQ is perpendicular to L1 and L2. Okay, so write down here, PQ vector is perpendicular to L1. PQ vector is perpendicular to L1. So here, before going to that, let me say the direction ratios. That's better. Let me first say the direction ratios of PQ. Direction ratios of PQ vector. For that, understand, this is P and this is Q. And how to find the direction ratios of a vector that connects 2 points? Just subtract them. Just subtract them. Z minus 2 by 2. Yes, it's Z minus 2 by 2 only, no? I haven't changed it. Z minus 2 by 2. So it's 2 lambda plus 2. Fine, it's correct. So PQ is equal to, subtract x2 minus x1, y2 minus y1, z2 minus z1. Quick, subtract it. 3 mu minus lambda, 3 mu minus lambda, minus 4 minus 6 minus 10. Y2 minus y1, minus 2 mu plus 2 lambda minus 2. Z2 minus Z1, minus 2 mu minus 2 lambda minus 1 minus 2 minus 3. These are the direction ratios of PQ. Now, going forward, what are the direction ratios of the line 1? Easy ones. You already know it. It's 1, minus 2 and 2. Direction ratios of line 2. Direction ratios of line 2. 3, minus 2, minus 2. I just found out the direction ratios of line 1, line 2. Just because I am going to use the condition for perpendicular vectors. Two vectors are perpendicular, then the dot product is 0. I'm going to use that. So that's why I'm getting my direction ratios ready. So I got the PQ, I got the L1. So I can start now. Direction ratios of PQ equals, just for not turning the pages again, 3 mu minus lambda minus 10. 3 mu minus lambda minus 10. Then minus 2 mu plus 2 lambda minus 2, minus 2 mu plus 2 lambda minus 2. The last one, minus 2 mu minus 2 lambda minus 3, minus 2 mu minus 2 lambda minus 3. Direction ratios of L1, direction ratios of L2. 1 minus 2, 2, 3 minus 2, minus 2. 1 minus 2, 2, 3 minus 2, minus 2. Start with the first pair of perpendicular vectors, PQ perpendicular to L1. The first PQ perpendicular to L1 means the dot product is 0. 1 multiplied to the first one, 3 mu minus lambda minus 10. Minus 2 multiplied to the second one, minus 2 mu plus 2 lambda minus 2. 2 multiplied to the third one, minus 2 mu minus 2 lambda minus 3 equal to 0. 3 mu plus 4 mu, 7 mu minus 4 mu, 3 mu. Minus lambda, minus 4 lambda, minus 5 lambda, minus 4 lambda, minus 9 lambda. Minus 10 plus 4 minus 6 minus 6 minus 6 minus 12 goes to the other side as 12. The simplified form, mu minus 3 lambda equal to 4, equation number 2, or can call it as equation number 3, equation number 3. Okay, I got one equation in terms of mu and lambda. Going for the second one, PQ perpendicular to L2, PQ perpendicular to L2. Okay, multiply 3 will with multiplied with 3 mu minus lambda minus 10, minus 2 multiplied with minus 2 mu plus 2 lambda minus 2, minus 2 multiplied with minus 2 mu minus 2 lambda minus 3. Okay, equal to 0. Equation 9 mu plus 4 mu, 13 mu, 13 mu plus 4 mu, 17 mu, minus 3 lambda minus 4 lambda minus 7 lambda minus 7 lambda plus 4 lambda minus 3 lambda, minus 30 plus 4 minus 26 minus 26 plus 6 minus 20 equal to 20, equation number 4. Now you have to solve these two equations. So better, no need to go for elimination. From here you can say mu is equal to 4 plus 3 lambda. Substitute here, 4 plus 3 lambda minus 3 lambda equal to 20. 17 fours are 68 plus 17 into 3, 51 minus 3 lambda equal to 20. 51 minus 3, 48 lambda equal to minus 48, lambda equal to minus 1. Lambda equal to minus 1, therefore mu is equal to 4 minus 3, which is 1. I got the value of lambda, I got the value of mu. Now there is no difficulty in finding the points. P is in terms of lambda, Q is in terms of mu. I am just writing the coordinates of P and Q. P, lambda is minus 1, so it's 5, 4 and 0. Mu is 1. Substitute mu as 1 here. In the second for Q, 3 minus 4 minus 1, 2 and 1. I got P and Q. The coordinates of the point where the distance between the two insects is the shortest. It looks a very, very different question. Okay? It's a very, very different question, but actually it's not lengthy. I wrote the first equation in Cartesian form. I wrote the coordinates of that point. Second equation in Cartesian form, coordinates of that point. Just 2 steps. I wrote the direction ratios of PQ by subtracting them. L1, L2 already there with me. Simply use the dot product. I got an equation in mu and lambda, another equation in mu and lambda. This is only just 6 steps. Solving the 2, I got the coordinates of the point. Now you have to just find the distance. You have to just find the distance, that's all. So what is the distance formula? You all know x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Use that. The first one is 36 plus 4 plus 1. The distance between the two lines or the two insects, the shortest distance between them is root of 41. Root of 41. So please, all of you, study this kind of question where you are supposed to find the shortest distance, not using the formula, but you have to find the coordinates of the points on the line where the distance is shortest, and then measure the distance between them by using distance formula. That's all. Not the shortest distance formula, direct root of x2 minus x1 squared, y2 minus y1 squared, z2 minus 1 squared. Okay? Clear? I think you have to practice this type of question for 5 marks. We don't want to take a chance. That's why. Okay? Can I move forward, please? I took a lot of time for explaining this question. So please, if you want to, make sure to come and study it back. The recording is available in YouTube. You can just come back and just watch it again. Okay. Find the vector and Cartesian equations of the line perpendicular to two lines. It's very simple question. You're supposed to find the equation of a line. Equation of a line perpendicular to two lines. Equation of a line perpendicular to two lines. It's very simple. R vector is equal to A vector plus lambda B vector is the equation of the line I'm searching for. And this B vector is going to be B1 cross B2. That's all. You're trying to find the equation of a line which is perpendicular to two given lines. Equation of the line is R vector is equal to A vector plus lambda B vector. A vector is the point that is given to me. Then B vector is going to be the cross product between B1 and B2 from both the lines. Okay, so here what's B1, B2? Here B1 vector, from the first line it's already in the standard form 1i, 2j, 4k. What is your B2 vector? 2i, it's already in the standard form, yes, 2i plus 3j plus 4k. So we just have to find B1 cross B2. It is determinant ijk 1, 2, 4, 2, 3, 4, I into 8 minus 12 minus 4 minus j into 4 minus 8 minus 4 plus k into 3 minus 4 minus 1. Minus 4, minus 4, minus 1. So you can take the minus out. Minus of 4i minus 4j plus k. If you want, you can write it. If you do not want, don't write it. No problem. So I got my vector. I got my A vector over here. Okay. So what is my vector equation? I plus j plus k. Lambda direction ratios 4i minus 4j plus k. You might be thinking, so what happened to the negative sign? Lambda is an arbitrary constant which can take any constant or a sign inside it but still remain the same. So minus can be taken by the lambda. So it's going to be I plus j plus k plus lambda 4i minus 4j plus k. And they're also asking you to write the Cartesian form. So it's going to be x minus 1, y minus 1, z minus 1. Direction ratios 4, minus 4 and 1 equal to lambda. This is the Cartesian form of the straight line. 5 marks question, my dear students. It looks so simple, but it's 5 marks. And because of that, so easy, they're asking you to find the angle between the two lines. I said, find the angle between the two lines could be a very good question for an additional question in the 5 mark criteria. Simply use the formula. Cos theta is equal to B1 dot B2 divided by magnitude B1 magnitude B2. Not going to waste my time finding that. Please, you have to do it. So here, how to find the vector equation of a line which is perpendicular to two lines? A vector plus lambda B vector. A vector will always be given the point on the line. B vector is the cross product of the two vectors already given to us. Okay? Next question. Find the Cartesian equation of a line that passes through the point. Point is given to me. And perpendicular to two lines. Just now we saw it. Yes. What is the equation of a line which is perpendicular to two lines? lambda b vector, and this b vector is always b1 cross b2. b1 represents what? Direction ratios of the first line. b2 represents direction ratios of the second line. My dear students, all of you look at the question. Here the first line is AB, line AB. The second line is CD. So what are direction ratios of B1? It is same as direction ratios of AB. How to find the direction ratio between 2 points? Subtract the 2 points. How to find the direction ratio between 2 points? These are all revised in the MCQs, and you all know it also. How to find direction ratios between 2 points A and B? Subtract them. You will get -3, -4, -2. Direction ratios of B2 is same as the direction ratios of CD. 2 minus 1, 1. 1 minus 2, minus 1. 1 plus 1, 2. Direction ratios of the second line. Then apply it like in the previous question. You will get B1 cross B2. Substitute. A vector is already there. A vector is already there with 1, -1 and 1 as the coordinates of IJK, or the coefficients of IJK. You just, I'm not going to calculate here, just telling you how to do this question. Find the direction ratios of AB, that's B1. Direction ratios of CD, that's B2. Find B1 cross B2. Substitute in the same way you did the previous question. But they want the final answer in the Cartesian form. Just do it like this. Give them the Cartesian form. After getting the vector form, give them the Cartesian form. That's all. So the question, the way you do it is your decision. Should I do it in the Cartesian form? Should I do it in the vector form? It's your comfort. Do it in whatever way you want. But the final answer, if they mention that they want in Cartesian form, just change it if you get your answer in the vector form. Or if you get your answer in the Cartesian form, but they want it in vector form, just change the final answer and give it to them. Okay? Clear, all of you? I believe everybody is clear. Yes? Next question. Find the equation of a line passing through the point and perpendicular to the two lines. Again, repetition. It's perpendicular to two lines. It's just for you to practice. Just take this question. If you want, you can practice it. Okay? Or you have other questions in worksheets, you can practice it. Just one more question of the same type. Question number 10. Find the value. It's a 2-mark question, my dear students. Find the value of lambda so that the two lines are perpendicular. If two lines are, or two vectors are perpendicular, then dot product of their direction ratios should be 0. Dot product of their direction ratios should be 0. All of you look at the first line, 1. Please write it in the standard form. It's 1 minus x. So it's going to be x minus 1 divided by -3. Yes? Next one, you have to divide the numerator and denominator with 7. Y minus 2 divided by 2 by 7 lambda. The third one, divide the numerator and denominator with 5. Z minus 2 divided by 11 by 5. I got the direction ratios of the first line in the denominator. For line 2, standard form, divide the numerator and denominator with -7 because the coefficient of x is -7. So it's x minus 1 by -3 by 7 lambda. Next one, y minus 5 by 1. Next one, z minus 6 by minus 5. So direction ratios of the second line is also ready. So I have b1 dot b2 equal to 0. So simply multiply minus 3 with minus 3 by 7. 9 by 7 lambda. 2 by 7 lambda with 1. It is 2 by 7 lambda. 11 by 5 with minus 5. It's minus 11 into 5 by 5 equal to 0. The dot product between the two direction ratios. 9 plus 2, 11 by 7 lambda. 5 minus 11 to the other side, it's 11. So that implies lambda is 11 into 7 by 11 and lambda is 7. Simple question. Find the value of lambda if the two lines are perpendicular to each other. Okay, so you just have to find the direction ratios of both the lines, and because it's for 2 marks, they will not give the equation in the standard form. You have to convert it. Please, my dear students, practice converting the Cartesian form of a line to its standard form before doing the question. Please make sure it's in the standard form. Otherwise, you are bound to make a mistake in the board exam. You will lose the 5 marks if you don't learn this. Next question. Find the coordinates of the foot of the perpendicular. Again, another 5 mark question. Finding the coordinates of the foot of the perpendicular from a point 0 to 3. From a point 0 to 3 to the line L. Okay, so I'm assuming that this point is P, this point is Q, and because it is unknown, I'm calling it as XYZ. But I do know that Q lies on the line L. Q, X, Y, Z lies on the line L, and we know L is X plus 3 by 5, Y minus 1 by 2, Z plus 4 by 3 equal to lambda. The same old technique, how to find a point on a line. How to find a point on a line. Write X, Y, Z in terms of lambda. X is equal to 5 lambda minus 3. Y is equal to 2 lambda plus 1. Z is equal to 3 lambda minus 4. X, Y, Z. Okay, now I got it. Now I can use the next condition that I know about perpendicular lines. If they are perpendicular, the dot product between the direction ratios is 0. Let's find out what are the direction ratios of PQ. PQ means X minus 0, Y minus 2, Z minus 3. These are the direction ratios of PQ. And we know X is 5 lambda minus 3. So 5 lambda minus 3, 2 lambda plus 1 minus 2, 2 lambda minus 1, 3 lambda minus 4 minus 3, 3 lambda minus 7. I got the direction ratios of PQ. What are the direction ratios of L? Given in the question, 5 to 3. The direction ratios of L is 5, Q, 3. Now, condition, PQ is perpendicular to L. If two vectors are perpendicular to each other, the dot product A1, A2 plus B1, B2 plus C1, C2. It's simply an expression to say I'm multiplying the corresponding direction ratios. A1, A2, B1, B2, C1, C2 equal to 0. Multiplied 5 with 5 lambda minus 3. 2 with 2 lambda minus 1. 3 with 3 lambda minus 7 equal to 0. 25 plus 4, 29 plus 9, 38 lambda. Minus 15, minus 2, minus 17, minus 21, 38. That implies lambda equal to 1. I got the value of lambda, my dear students. If lambda is ready, next step, pretty easy. Therefore, what is Q? Lambda is 1. 5 minus 3, 2. 2 plus 1, 3. 3 minus 4, minus 1. That is the foot of the perpendicular. This Q is the foot of the perpendicular from the point to the line. Same idea. You have done this question of insect, where you have said that the line is making a perpendicular from the distance. So we are actually finding the point which is called the foot of the perpendicular of that line. So always represent the coordinates in terms of lambda and then use the perpendicular condition equal to 0. Here when I used it, I got lambda equal to 1 and substituted lambda equal to 1. I got the coordinates of Q, which is 2, 3, minus 1. Right answer, Nitin, 2, 3, minus 1. And now you're supposed to find the length of the perpendicular, which is PQ. Therefore, length PQ. Very simple. Distance between the 2 points. 0 and 2 squared. Okay? 2 minus 3, 1 squared. 3 plus 1, 4 squared, 16. Root of 21. Root of 21. Is it clear, all of you? Yes? Is it clear, all of you? If any doubts, please ask. If you have any doubts, please ask. It's a very good question, again for 5 marks. Finding the foot of the perpendicular. Finding the foot of the perpendicular. Okay, next question please. Find the image of the point. Same concept, same question. The only difference is at the end, instead of finding the length of the perpendicular, they're asking you to find one more point called image. This is 163, which again is my point P, and this point makes an image in this line L. Okay, and the image will be exactly on the opposite side of L at a distance which is equal on both sides, and we know this midpoint is Q. So they did not mention the word foot of the perpendicular, but when you're finding the image, it's necessary that you find the foot of perpendicular. So I do not have to explain how to find the foot of perpendicular. You all have just seen in the previous question. Going straight away, Q equal to XYZ is the foot of perpendicular on the line L, and the line L is x by 1, y minus 1 by 2, z minus 2 by 3 equal to lambda. So x is equal to lambda, y is equal to 2 lambda plus 1, z is equal to 3 lambda plus 2. I got the coordinates of x, y and z in terms of lambda. That's the foot of the perpendicular. The same idea, direction ratios of PQ. X minus 1, y minus 6, z minus 3. Substitute x and y and z in terms of lambda. Lambda minus 1, 2 lambda plus 1 minus 6 minus 5, 3 lambda plus 2 minus 3, 3 lambda minus 1. This is the direction ratios of PQ. Direction ratios of L: 1, 2, 3. So I got the same method. I am trying to find the foot of the perpendicular Q here. Therefore, PQ perpendicular to L implies A1, A2 plus B1, B2 plus C1, C2 equal to 0. Simplify it. 1 to lambda is lambda minus 1. 2 to 2 lambda minus 5, 4 lambda minus 10. 3 to 3 lambda minus 1, 9 lambda minus 3 equal to 0. Lambda, 4 lambda, 9 lambda is 14 lambda. Minus 1, minus 10, minus 11, minus 3, minus 14. Again good. We got lambda equal to 1. Lambda equal to 1. Therefore, what are the coordinates of Q? Lambda equal to 1. Therefore, what are the coordinates of Q? Where is Q in terms of lambda? This is my Q in terms of lambda. 1, 3, 5. Substitute lambda equal to 1, 1, 3, 5. Got the coordinates of the point Q in 1, 3, 5. So I got this 1, 3, 5. Now I'm supposed to find the image P dash. So let me assume that this unknown point is ABC. Let me call it as ABC. But I know that Q is the midpoint of Q is the midpoint. I said both the distances should be equal to form the image. Midpoint of P and P dash. Q is the midpoint of P and P dash. Midpoint formula, 11th standard 3-dimensional geometry. 1 plus A by 2 is the midpoint 1. From this, A is equal to 1. 6 plus B by 2 equal to 3. Here B equal to 0. 3 plus C by 2 equal to 5. C is equal to 7. I got the coordinates of each point on the image. So P dash is equal to 1, 0, 7. The image P dash is equal to 1, 0, 7. Clear all of you? All of you clear? Any doubts? Image of the point, again a good question for 5 marks, like finding the length of the perpendicular. Okay? Same type of question, not going to waste my time doing this. Find the equation of the line passing through the points A, B, D is the foot of the perpendicular drawn from the point C and on the line AB, then find the coordinates of D and the equation of CD. It's about finding the foot of the perpendicular on AB. Find the equation of the line joining A and B. D is the foot of the perpendicular drawn from the point C, okay, on AB. Find the coordinates of D and find the equation of line CD. Straight, same question, practice it. You know how to find the coordinates of D, the foot of the perpendicular. Now you have 2 points C and D. You can find the equation of line CD as x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. Not going to waste my time teaching you again how to find the foot of the perpendicular. I did already 2 questions on how to find the foot of the perpendicular. You just have to find the equation of that line CD using the idea x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. Try it out, my dear students. A good question for your boards. A line passing through the point A with position vector is parallel to the vector B. Find the length of the perpendicular again on this line from a point P. So instead of giving you the coordinates, they are giving it in vectors. So you're trying to find this, which is I plus 2j plus 3k. Okay, and you're trying to find the perpendicular drawn from this onto this line, which has A vector and B vector. This is the A vector and this is the B vector. So I have the equation of line L. I have the equation of line L. Use that equation of line L to find the foot of the perpendicular Q. That's all. And then find the length of the perpendicular PQ. Same question, they are just modifying on how the question is asked. They're just modifying on how the question is asked. Note this question down. Take a picture of the question if you want to practice at home. Take a picture of the question. Do it. Make sure it's done. Make sure you practice this question also. Find the point on the line which is at a distance of 3 root 2 from the point 1, 2, 3. Good question for 2 marks. A very good question for 2 marks. Find the point on this line which is at a distance of 3 root 2 from the point. So let's say that point is x is equal to 3 lambda minus 2. Find the point. So 3 lambda minus 2. Y is equal to 2 lambda minus 1. Y is equal to 2 lambda minus 1. Z is equal to 2 lambda plus 3. This is the first point given to us. The second point is 1, 2, 3. They are saying that the distance between these 2 points is 3 root 2. The formula for distance, we have been using this for so many times, but this is the first time I'm writing that formula actually, because it's a very common formula from 11th standard itself, where everybody is supposed to know that the distances between 2 points is x2 minus x1 squared, y2 minus y1 squared, z2 minus z1 squared, and the root is equal to d. So 3 lambda minus 2 minus 1, 3 lambda minus 3 squared, 2 lambda minus 1 minus 2, 2 lambda minus 3 squared, 2 lambda plus 3 minus 3, 2 lambda squared is equal to 3 root 2 squared. I just squared the distance on both sides to get rid of the square root. Now you know how to open the bracket up. 9 lambda squared, 918 lambda plus 9. 4 lambda squared minus 12 lambda plus 9 plus 4 lambda squared equal to, now 3 squared is 9, 9 2s are 18. Okay, so you can see that very clearly. 9, 9, 18 cancels over here. Now you have only lambdas. 9 lambda squared plus 8 lambda squared, 17 lambda squared. Then minus 12 lambda minus 18 lambda, you can say minus 12 30 lambda equal to 0. So lambda into 17 lambda minus 30 equal to 0. Lambda equal to 0. 17 lambda minus 30 equal to 0. So once again, the idea behind this question, finding the coordinates of a point. Again, write the coordinates in terms of lambda. The distance between them, 3 root 2, square both sides. Get the value of lambda. I got 2 values for lambda. One is 0, the other one is lambda is equal to 30 by 17. It's a 2 mark question, so you can find both the values of P, lambda equal to 0, P equals -2, -1, 3. Lambda equal to 30 by 17. P equals 90 minus 34. 56 by 17. 60 minus 17. 43 by 17. 60 plus 51. 60 plus 51, 111 by 17. So these are the coordinates of P for the two values of lambda. Okay, once again, good question for 2 marks. Distance between 2 points where 1 point lies on this line. So I have supposed to find the value of lambda using the idea of a point in a line. Okay, and then the distance is 3 root 2. Using that, I got the value of lambda. Substitute that, I'll get the points. Because it's a subjective question, you have to show both. Okay, the equation of a line, again, I'm not going to explain this. You know how to find the direction ratios. Yes, direction ratios. And then how to find the direction cosines. Direction cosines is direction ratios divided by the magnitude. Yes, I believe everybody knows this. Yes, from this you can find the direction ratios. I already taught you many times on how to convert a line into its standard form, get the direction ratios and divide with its magnitude. You know how to find magnitude from the direction ratios. Just do it. Please practice this. It's like a textbook question. You've done this in class also so many times maybe. Please practice it. Okay, it's a good question for 2 marks. Good question for 2 marks. This one, very important question. Please learn it. If alpha, beta and gamma are the angles made by a line with the axis, then the only relationship that should come to your mind is cos squared alpha plus cos squared beta plus cos squared gamma is 1. If alpha, beta, gamma are the angles made by a line with each of the axis x, y, z, then cos squared alpha plus cos squared beta plus cos squared gamma equal to 1. Equation number 1 says find or prove this is equal to 2. From this I can write cos squared alpha is 1 minus sin squared alpha. Cos squared beta is 1 minus sin squared beta, or better to say the reverse way. They're asking you to prove something. Let's straight away take the question. Sin squared alpha plus sin squared beta plus sin squared gamma. This is 1 minus cos squared alpha, 1 minus cos squared beta, 1 minus cos squared gamma, which is 3 minus cos squared alpha, cos squared beta, cos squared gamma, which is 3 minus 1, 2. Easy question. It's good for MCQ also. I have done this in the MCQ section. Please go and do it. I'm going to teach this again because it's good for 2 mark also. Learn it, how it's done. All of you please look at it, how it's done. Okay. Next part, cos 2 alpha plus cos 2 beta plus cos 2 gamma, which is 2 cos squared alpha minus 1, 2 cos squared beta minus 1, 2 cos squared gamma minus 1. 2 into cos squared alpha, cos squared beta, cos squared gamma minus 3. And what is the sum of cos squared alpha, cos squared beta, cos squared gamma? It's 1. So it's 2 minus 3, which is minus 1. So it's a simple proof you can do. Could be a 2 mark question or could be a 1 mark question for MCQ. Please learn both of these questions thoroughly. it's good to be asked. Okay? Again, this was done in MCQ. The direction cosines of a line which makes equal angles with the coordinate axis. It's 1 mark question, not 2 mark. If you want, you can learn it by heart, or you can just go to the MCQ section for watching this again on what is the direction cosines of a line which makes equal angles with each of the axes. 1 by root 3, 1 by root 3, 1 by root 3. If a line makes 90 degrees, 60 degrees respectively with each of the axes x and y, then what is the angle made with the z-axis? Just now we said cos squared alpha, cos squared beta, cos squared gamma is 1. First angle 90 degrees, cos squared 90. Second angle 60 degrees, cos squared 60. Third angle cos squared gamma equal to 1. Cos squared 90, cos 90 is 0. Cos squared 60, 60 is 1 by 2, so it's 1 by 4 plus cos squared gamma equal to 1. So cos squared gamma is equal to 1 minus 1 by 4, which is 3 by 4. So cos gamma is root 3 by 2, which implies gamma is equal to 30 degrees. And please understand, it is plus or minus. If it is positive, it is 30 degrees, or the negative part says gamma is 180 minus 30, which is 150, the supplementary angle of 30 degrees. You have to mention both. Both are possible answers. You have to mention both. Both are possible answers. Very good question for 1 mark. Very good question for 2 mark also. They can ask this for 1 mark or 2 mark. It's their choice. So the only equation you have to memorize when the angle made by a line with all of the axes is given, everything revolves around which equation? Cos squared alpha plus, cos squared beta plus, cos squared gamma equal to 1. Writing that alone guarantees you half mark. And then substitute whatever is given to you to come to the final answer. Okay? Not going to waste my time. Find the vector equation. Please do it. Okay? Now next, I have a very short time, so we will start with vector algebra. So I just want you to just recollect on what all we did today in 3D geometry. 5 mark questions and 2 mark questions. 5 mark, 2 mark. 5 mark shortest distance, image of a point, point of intersection between two lines, and also the insect based question where you're finding the actual points which makes the shortest distance and then measuring the distance. Very important. Okay, once again, shortest distance between two lines, angle between two lines, the foot of the perpendicular and image of a point, the point of intersection of two lines, the line perpendicular to two lines. These are all very good questions for 5 marks. Okay, please, you have to study them very well. You are getting 1 question for 5 marks from 3D geometry, and then so many 2 mark questions, and most important 2 mark question is the last part which I discussed, which gives the relationship between a line that makes angles alpha, beta, gamma with each of the axes. Alpha, beta, gamma with each of the axes. Okay, just settle down, 1 minute, just try to recollect what we did in 3D.
Your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.
Okay, now let's start with vector algebra. Again, vector algebra, I said, you don't have to force yourself to study so many difficult questions. Vectors, 1 mark questions. Yes, I have discussed a lot of 1 mark questions in the MCQ discussion. According to sample paper, 3 questions of 1 mark is coming from vectors. And then just 1 question of 2 mark. Okay, so we're just going to do some basic questions of 2 mark in vectors. Okay, find the first question. Find a vector of magnitude 5 which is parallel to the resultant of. What is the meaning of resultant of? It means the sum of A and B. So what is A plus B? Add the 2 vectors. 3i plus j plus 0k. This is the resultant vector A plus B. Okay? Five mark, 1 3D mark question comes for 5 mark, 1 3D question for 2 mark, and it's expected to have 2 1 mark questions also from 3D. Total of 8 marks. That's the expectation I'm having. That's why I'm saying like this. Okay? Fine. Now, A plus B is there. How to find a vector parallel to a given vector? A vector parallel to C. How to find it fast? It's very simple. Just divide C with its magnitude. If you want to find a vector which is parallel to itself, then you have to divide that vector with its magnitude, which is often called as unit vector. That is equal to 3i plus j plus 0k magnitude 9 plus 1 plus 0. That is 3 by root 10 I j 1 by root 10 plus 0 by root 10 k. This is the vector which is parallel to both, to the resultant of A and B. Now they want that vector to have a particular magnitude called 5. So the last step, what should I do? A vector with magnitude, a vector with magnitude 5. I want a particular vector which is parallel to the resultant A plus B, and it should have magnitude 5. If you multiply this C cap, the unit vector C cap with 5, because C cap is having magnitude 1. If you multiply that vector with 5, you will get another vector with magnitude 5, but still parallel to A plus B. Got it? 2 ideas coming in the question. To find a vector parallel to A plus B, divide that vector with its magnitude, which is called unit vector. How to make it have a different magnitude? Multiply with that magnitude. So your answer, 15 by root 10 I, 5 by root 10 j, 0 k. Okay, so this is the vector with magnitude 5. Easy question, good for 2 marks, even good for 1 mark, but there is a little bit more to do. That's why I said it's 2 marks. Okay, read the next question please. Sorry. 22. Find the position vector of R which divides the 2 vectors in the ratio 2:1 internally. So the position vector of R internally means in the ratio m:n. In the ratio m:n. The first vector may be called as A, the second vector may be called as B, then R vector is M multiplied with B vector, N multiplied with A vector by M plus N. For externally, R vector is equal to M B vector minus N A vector by M minus N. This is the formula in which a particular vector divides the join of two vectors in the ratio M is to N. Okay, so just keep multiplying 2 with the first vector, 2 with the second vector, minus 2i plus 2j plus 2k. Add that with 1 with the second vector, I plus 2j minus k divided by 3. Minus 2 plus 1 minus I by 3. 2 plus 2, 4j by 3. 2 minus 1, 1k by 3. This is the position vector of R, which divides the join of A and B internally in the ratio 2:1. Let's try externally. The same thing but subtracted. Minus 2i plus 2j plus 2k is MB subtracted with I plus 2j minus k divided by M minus N, which is 1. Minus 2 minus 1 minus 3i. 2 minus 2, 0j. 2 plus 1, 3k. This is the position vector of R, which divides the join of A and B externally. Simple but important. Simple question but very important. Learn it. Next question. Find the magnitude. I am expecting this question, very important, for 2 marks this time. In a different way, the question I have framed it. Find the magnitude of the projection of the vector. You haven't maybe seen this in the normal classes. Can they ask definitions? Yes. MCQs, they can ask anything. Definitions, concepts, simple understanding ideas of a particular topic, they can ask you anything in MCQs. So basic, study everything from the textbook. That's how you can cover up MCQs. But for 2 marks, no. Find the magnitude of the projection. What is the meaning of this? It simply means the scalar projection. What is the meaning of magnitude of the projection? What is the meaning of magnitude of the projection? It simply means scalar projection. And the scalar projection is A dot B by magnitude B. A dot B by magnitude B. Dot product between the vectors 1 into 7. Then 3 into minus 1. 7 into 8 divided by the magnitude of the second vector 49 plus 1 plus 64. Okay, 7 minus 3, 4, 4 plus 56, 60 divided by root of 114. 60 divided by root of 114. This is the magnitude of the projection of A on B, or scalar projection. Then I want you to find, hence find its projection vector. Hence, I'm expecting this for 2 marks, that's why I'm repeatedly telling you, find the magnitude of the projection and then find its projection vector. What is the projection vector or vector projection? It simply says A dot B by magnitude B squared, this answer is multiplied with vector B. A dot B by magnitude. You know what is A dot B? It's already done. 60. You know what's magnitude B and square it. It's 114. This answer is multiplied with the B vector 7i minus j plus 8k. Learn the difference in the formula, all of you. Normally, magnitude or scalar projection is A dot B by magnitude B. But vector projection is A dot B by magnitude B squared multiplied with B. Okay, fine. So 60 and 114, if you want, you can simplify it. Yes, this goes in. Yes, it goes in 2. It's going to be 2, 5, 57. This is 30. Multiplied inside. 7 3s are 210 by 57i minus 30 by 57j plus 240 by 57k. Answer for projection vector. Next question. The scalar product of the vector ijk with a unit vector along the sum of unit vector along the sum of. Along means parallel to. The first question we did was based on this. How to find a vector that is parallel to the sum of. It was said resultant of, now it is sum of. So what is it? 2 plus lambda I. So what is the sum of A plus B, all of you? What is the sum of A plus B? This is A, this is B. Sum of A plus B, 2 plus lambda I plus 6j minus 5 plus 3 minus 2k. This is A plus B. I have to find a vector along the sum of. So therefore C cap. Vector along the sum of means C cap. That is 2 plus lambda I 6j minus 2k will be divided with its magnitude 2 plus lambda squared plus 36 plus 4. Okay, this is unit vector. They are saying the scalar product of. What is meant by the scalar product of this particular vector? Let me call it as D. Okay, I've used C, so let me call it as D. The scalar product of D with C cap. It's with C cap. D with C cap is equal to 1. So take this dot product. 1 with 2 plus lambda. Okay. 1 with 6. Okay. And then one more 1. 1 with minus 2. Divided by the magnitude 2 plus lambda squared plus 40 equal to 1. Got it? The dot product between D and C cap is 1. So I took the dot product of the C cap with D and I got it in terms of lambda, pure scalar. So simplify it. 2 and minus 2 will cancel. Okay, so you get lambda plus 6. Take this to the other side. Square root of 2 plus lambda squared plus 40. Now, if you want to simplify and get lambda, square both sides. So lambda plus 6 squared is equal to lambda plus 2 squared plus 40. So lambda squared plus 12 lambda plus 36 equal to lambda squared plus 4 lambda plus 44. Lambda squared cancels on both sides of the equation. You get 8 lambda equal to 8. Lambda equals 1. Another very good question for 1 mark. Once again, idea is enough. No need to by heart it. They're asking you to find a vector which is along the sum of, means parallel to the sum of the two vectors. So how to find a vector parallel to the sum of A and B? Add A and B, divide by its magnitude. And the dot product or the scalar product of I plus j plus k with that unit vector is 1. I got it as a scalar, I squared it. Yes? Clear answer all of you? Moving forward to the next question, please. A, B and C are 3 vectors where A is 3 magnitude, B has magnitude 4, C has magnitude 5, and each one of them is parallel to the sum of the other two. That is not parallel, perpendicular. A is perpendicular to B plus C. One vector is perpendicular to the sum of the other two. Perpendicular, we know that if a vector is perpendicular to another, their dot product is 0. If one vector is perpendicular to another vector, the dot product, we have seen a lot of questions in the MCQ discussion and as well as in vector and 3D subjective questions also. A dot B plus C equal to 0. So can I say A dot B plus A dot C equal to 0? Equation number 1. Now they said it doesn't happen only with this condition. Not only A perpendicular to B plus C, every vector is perpendicular to the sum of the other two. So if I use that idea, similarly, B will be perpendicular to A plus C. So B dot C plus B dot A is 0. Equation number 2. C dot B plus C dot A equal to 0. Equation number 3. This is what I got from the statement that every vector is perpendicular to the sum of the other two. Now can you please add 1, 2, 3. Please add 1, 2, 3. A dot B, A dot B. 2 times A dot B. B dot C, B dot C. 2 times B dot C. A dot C, A dot C. 2 times A dot C equal to 0. This is what I got on adding the 3 equations I got. Okay. Now the idea for this question. All of you please listen to what I'm saying right now. Can you see that this question talks about some magnitude of some vectors? And do you see that they're asking you to find an expression which involves the sum or maybe even difference of 2 or more vectors? When the question is always this, square that sum or difference. Always. The idea behind squaring is a vector squared is same as is magnitude squared. A vector squared is same as is magnitude squared. So I have the square of A plus B plus C. It's same as squaring A plus B plus C. So it is A squared plus B squared plus C squared plus 2 times, because it is vector, it is dot product, 2 times A dot B, B dot C, C dot A. Just now I told you vector squared is magnitude squared, magnitude A squared, magnitude B squared, magnitude C squared plus 0. Why is that side 0? Just now I proved 2 times of that dot product is 0. Magnitude A, 3, 4, 5. 3 squared 9, 4 squared 16, 5 squared 25, which is 50 over here. Therefore the magnitude of A plus b plus c equal to root 15, which is 5 root 2. Keep the idea in mind, all of you. Keep the idea in mind. Whenever you have a question about magnitudes of certain vectors and there is an expression which talks about sum or difference of two vectors, always square it. You square it, you always bring this idea to your mind that square of a vector is same as its magnitude squared. Moving on. 26. A is given, B is given, C is given. You are supposed to find a vector D which is perpendicular to both A and B. A very important condition. Finding a vector which is perpendicular to both A and B. D is perpendicular to both A and B. Normally, if somebody asks you a question like this, find a vector which is perpendicular. Find a vector. Understand, if you have A and B like this, I can find infinite number of vectors which are perpendicular to both A and B. Okay? I can find infinite number of vectors which are perpendicular. They need not be parallel because it is 3-dimensional space. I can find infinite number of vectors which are perpendicular to both A and B. But I am supposed to find a vector which is perpendicular. So I'll simply say D is equal to A cross B. The shortest technique to find a vector which is perpendicular to two other vectors is take the cross product. But now there's a problem here. The problem is not only they should be perpendicular to both A and B, there is one more condition associated with D, that C dot D should be 15. And because of that reason, I am forced to do something here, to put a lambda. From this infinite vectors, I have to take out one vector which gives me a value for lambda in such a way that the dot product with C is 15. That's the star of the day. Finding a vector which is perpendicular to both A and B is pretty easy. Simply take the cross product. It could be any one of these vectors where I assume that lambda is 1. Lambda could be any number. I am assuming lambda is 1. Infinite numbers are there, right? 1 is one of the infinite numbers that you know. So put lambda is equal to 1, finished. But here I cannot put lambda equal to 1 because there is a second condition which says C dot D is equal to 15. So we have to find what's A cross B. All of you, A cross B equal to determinant ijk. A is 1, 4, 2, 3 minus 2, 7. I into 28 plus 4, 30. Minus j into 7 minus 6, 1. Plus k into minus 2 minus 12 minus 14. So that implies vector D is equal to 30 lambda I minus lambda j minus 14 lambda k. This is my D vector. I don't know what is lambda, but just leave it in terms of lambda itself. Because I have a second condition which says C dot D equal to 15. What is the second condition that exists in the question for us? Dot product with C and D is 15. So what's C for us? 2 minus 1, 4. Take the dot product. 2 into 30, 60 lambda. Minus 1 into minus lambda plus lambda. 4 into minus 14. So it's 16, 56 lambda equal to 15. 60 plus 1, 61. 61 minus 56, 5 lambda is equal to 15. Lambda equal to 3. Lambda equal to 3. Substitute that, all of you, in D. Therefore, D vector is equal to D vector is equal to 150I minus 3J minus 42K. So I have two vectors A and B whose cross product with lambda gives me the D vector, and then dot product with C gives me 15, right? So I just use C dot D. So 2 into 330, which is 60 lambda, minus 1 minus lambda plus lambda, 4 into minus 14 minus 50. So 61 minus 56 is 5 lambda is equal to 15. So lambda equal to 3. Substitute that in D. I get the vector for made a mistake here. Where? Lambda, okay. 90, sorry. Sorry. Just a minute. There's been a calculation mistake here. It's not 30, it's 32. Sorry, just change it, all of you. So it's 28 plus 4 is 32I. 7 minus 6 is 1. That's right. Minus 2 minus 12 is minus 4. It's 32 here. Please make a change, all of you. 32I. 32I minus lambda, 32 lambda I. So I'm just making a change, all of you. Mistake in the calculations. So you have to take dot product with this D. 2 and 32 is 64 lambda plus lambda minus 56 lambda equal to 15. C dot D. Sorry, please make a change, all of you. All of you, please make a change. Okay, so 64 plus 1, 65. 65 minus 56 is 9 lambda equal to 15. Lambda is equal to 5 by 3. Lambda is equal to 5 by 3. Okay, therefore what's D? 32 into 5 by 3 I minus 5 by 3 J minus 14 into 5 by 3 K. So it's 160 by 3 I minus 5 by 3 J minus 70 by 3 K. I'm sorry, my dear students. So calculation mistake, it was not 30, it was 32. That's why we got a different answer. Please correct it, all of you. All of you, please correct it. Remember why I took lambda? Because normally lambda is 1, but we have a second condition about the vector D. So I cannot assume that lambda is 1 and go. So I had to find that lambda for which C dot D is 15. Okay? A and B are unit vectors. So definitely magnitude of A and magnitude of B is 1. And they said to find the theta is the angle between the two vectors, show that sine theta by 2 is half magnitude A minus B. Again the same technique. What's the technique, my dears? If you have the sum or difference of two vectors and there is a magnitude involved in the same question, take that expression and square it. Yes, which is same as the vector squared, which is A squared plus B squared minus 2A dot B. A squared is same as magnitude A squared, B squared is same as magnitude B squared, and what is A dot B? You should all be knowing this already from vector discussions of MCQ. A dot B is magnitude A, magnitude B, cos theta. There is a formula which connects the angle between the two vectors and A dot B. A dot B by magnitude A, magnitude B is cos theta. So A dot B is equal to magnitude A, magnitude B, cos theta. Similarly, cross product says magnitude of A cross B is magnitude A, magnitude B, sin theta. This is two very important relationships we had used in many questions in 1 mark MCQ. So here this is going to be magnitude A, magnitude B, cos theta, my dears. A dot B, right? Cos theta. And we have magnitude of A and B as 1. So substitute 1 plus 1 minus 2 cos theta, which is 2 minus 2 cos theta, which is 2 into 1 minus cos theta. So magnitude of A minus B squared is 2 into 1 minus cos theta. And 1 minus cos theta, everybody, one of the most important trigonometric results in 11th and 12th. 1 minus cos theta. Quickly, if you can remember, you can put it in the chat box. 1 minus cos theta, 2 sine squared theta by 2. Then what's magnitude of A minus B? Not squared, A minus B. It's 2 sine theta by 2. Okay, now bring sine half here. So it's going to be half magnitude of A minus B equal to sine theta by 2. Half magnitude of A minus B is sine theta by 2. There's one more question very similar to this. The question is, it would be also cos theta by 2 is equal to half magnitude of A plus B. A very similar question. You just have to square A plus B. You will get 1 plus cos theta, which is 2 cos squared theta by 2. Idea is the same. Practice this yourself. Practice this yourself. Idea is a textbook based question. Very high chance of being asked. Okay? Think we have time for one more question. Please look at this question. Here they're saying about A plus B plus C equal to 0. Magnitude of A is 3. Magnitude of B is 5. Magnitude of C is 7. Find the angle between A and B. A plus B plus C equal to 0. I am only concerned about the angle between A and B. So I just push the C to the other side. Now I'll square. If you straight away square without doing this, C also will get involved in the answer. We don't want C. So square both sides. Magnitude A plus B squared is magnitude C squared. And all of the vectors say their magnitude. So here A squared plus B squared plus 2A dot B equal to magnitude C squared. A squared 9, B squared 25. A dot B, already the formula was discussed in the previous question. AB cos theta, C squared 49. Substitute all the values possible. 2 into 3 into 5 cos theta equal to 49 minus 34. 49 minus 34, 15. So cos theta is 1 by 2, implies the angle between A and B. Angle between A and B is AB cos theta. Yes, theta is 60 degrees. Preferably the answer pi by 3. Pi by 3. Yes? So, please study the difference between the previous a plus b plus c and this a plus b plus c. I did not square straight away because I am only concerned about the angle between a and b. So I took c to the other side and then I squared it. I believe everybody was clear with today's questions. There are a few more questions in vectors you have to practice. Please keep doing it. The ideas are the same. So I will come back again today. Today night we have a session on continuity, differentiability and applications of derivatives. So I expect all of you to be present for that session at 7 o'clock Doha time. So see till then, see you all. Thank you and have a very nice day.
Good morning.
Good morning. What's all this? Your results. Congratulations to all. I'm confident you'll all achieve your goals. So young man, what are your aspirations?
I want to do robotics, ideally from the Bust Institute in the US.
And you, young lady?
Sir, I love kids and I would love to learn pediatrics. I feel Boston is the best place for that.
Sumit, what about you?
Back home to India for medicine.
Good. I'm sure you'll all achieve your aspirations, be it in India or anywhere. Keep in mind, your first challenge is the entrance, whether it's IIT, JEE, SAT or NEET. You have to learn from the masters. Brilliant Qatar is the passport to your success.
We undertake coaching for regular and repeat batches and tuition for board examinations. Brilliant Education Centre, Doha, Qatar